Hey everybody, we are going to be trying to find probabilities for these things called binomial random variables. But before we actually get there, we have to figure out what is a binomial random variable. It ends up being a pretty easy process to check. There's these conditions that we will run our variable through. These conditions really break down in a nice little acronym when you're thinking about binomial, because it starts off with the letters BIN. So fantastic way to remember these conditions is always check. In order to be binomial, you always check the bins. The bins, B-I-N-S. It's a fantastic way of remembering what the conditions are for being a binomial random variable. So I'll list each condition, give you a brief example, and I think that should be good enough for this video. So the B stands for binary. In terms of binary for these variables, that just means you have two outcomes only. Exactly two outcomes. And typically, these outcomes are labeled success or failure. You identify one outcome or one set of outcomes as success and the other outcomes as failure. Binary, only two options. The next thing is the I stands for independent. Independent. And this just means, of course, knowing previous outcomes. Knowing previous outcomes does not affect the probability. Knowing previous outcomes does not affect the probability. So when you're thinking of like drawing cards from a deck, if I drew an ace on my very first card, we know that, well, I started off with 4 aces in that deck of cards out of 52 cards total. If I drew an ace first, and this is what I was looking for, that probability changes. It goes down to 3 out of 51. This is not binomial. You don't want to see this kind of stuff. Those events would not have been independent, making your random variable not binomial. So binomial independent outcome would be like flipping a coin. It has no memory. If I rolled heads, that probability is 0.5. The probability that I roll heads again is still 0.5. Knowing that I roll heads already does not affect the probability of my next flip. And that's all we're talking about in terms of independent with these binomial random variables. All right, almost done. We're halfway through. The next thing is n. N is the number of trials is set. What I mean by this is it's perfectly okay to say we are going to flip a coin 10 times. We've set the number of times we're going to flip this coin. That's what you want to see for a binomial random variable. What would not be so good is something like this. Flip a coin. Flip a coin until you get tails. So this is not set. I could flip the coin 5 times. I could flip it 6 times, 7, 8, maybe 2, maybe the first try. We have no idea how many times it's going to take to get a coin to flip and land tails up. Not binomial. Binomial, we have to have a set number of trials. Specified already. Like I'm going to flip the coin exactly 10 times and then record the number of times I get tails. That's a binomial random variable, not something like this. And the last thing is success. In terms of probability, remains constant. Success remains constant. So again, it really ties into independence, but if I started off with the probability of something like 0.34 on the very first trial, the second time I perform this trial, the probability of success would have to be 0.34. There can be no variation in the probability of success as you complete your trials. So I guess the difference here between independence is we can have an independent binomial random variable if we like flip a coin first, flip a coin, and then roll a die. And we could define success as being like when I flip the coin, I've got heads, and when I roll the die, I get a 1. So these two things are independent. The probability of success in this case would have been, 1/2 for getting tails. Maybe I said heads earlier, I don't remember. And then 1/6 for rolling a 1. So every time I perform this process, this random process, my probability of success is 1/12, making it okay. Again, we just need to have these events be independent, and the probability of success has to remain constant every single time you run the trial. That really does it for binomial random variables. As you approach these problems today, just remember to check the bins. Binary independent, have a set number of trials, and the success remains constant every time you complete a trial. All right, that'll do it for this video. Thanks for watching. Bye.